So here we have first problem. You can read the question. We have charge is given, the speed is given, and also magnetic field is given. So we have to find magnetic force on the plane. So basically it's very simple. So using the formula will be FB is equal QVB. So this is our first problem. So Q is given, speed is given, and B is given. So you just have to multiply all of them and you will get the answer. For the second question, we have given the speed is given, the force is given, and angle is given. So we have to find magnetic field. So let me write it down. So in the second problem, we have to find the B. So again, the formula will be FB, magnetic force, is equal QVB sine theta. Okay, so angle is given, everything is given, we have to find the B. So the B is equal FB, magnetic force, divided by QV and sine theta. So once you substitute numbers, you should get the answer. Okay, problem number 3. So if you read the question, we have speed is given, magnetic field strength is given, what is the radius of the circular path the electron follows. Okay, so in the third problem, we have given the speed, we have given magnetic field, we have to find R. So we know that magnetic force will be equal to the centripetal force. From there, magnetic force is equal QVB, and that one's equal is mv squared over R. So 1v. So the R is basically equal to the mv over QB. Now the mass of the electron and the charge of the electron. So the mass of the electron is given, which is 9.1 times 10 to the power of minus 31, and the charge itself is 1.6 10 to the power of minus 19. And when you substitute, you should get the answer. Okay, what is next? The next problem is 4. In the first problem, we have oxygen, the mass is given, speed is given, magnetic field strength is given, the radius is given of circular arc. What is the positive charge is on the ion? Okay, what is the positive charge of the ion? So in the first problem, what we have, okay, so let me write it down. First problem, we have mass is given, the speed is given, magnetic field is given, and radius is given. So you have to find what is the charge Q. Again, using same formula where FB is equal to the FC. This one is a QVB is equal mv squared over R. So we cancels, so the Q is equal mv over BR. So basically you have everything. When you substitute, you should get the answer. Okay, problem number 5. If you read the question, you can see that we have speed, we have magnetic field. What is the strength electric field must be applied perpendicular to the earth field to make electron moves in a straight line? So when it has to move straight line, then magnetic field and electric field has to be balanced. They should be equal. So let me write it down. So question 5, V is given, then B is given. We have to find electric field when it flows a straight line. So magnetic force will be equal to the electric force, electrostatic force. So magnetic force is equal QVB is equal QE. So Q cancels out. So the simple electric field is equal VB. That's it. So you plug numbers, you should get the answer. Okay, problem number 6. We have alpha particle, the mass is given, the amount of charge is given, travels in circular path of radius 25 centimeters. Radius is given, uniform magnetic field is given. What is the speed of the particle? Okay, that is traveling. So problem number 6. The mass is given, Q is given, and R is given, B is given. You have to find a V. Okay, so how can we find it? So basically, there's a formula where you can use for that one to find the V. Is basically V is equal charge multiplied B multiplied radius divided by the mass, and when you plug the numbers you should get the answer for this particular question. Okay, problem number 7. What is the force per meter on a lightning bolt at the equator that carries current ampere perpendicular to the Earth's magnetic field is given? So force per meter, you have to calculate it. So what is given? So in this problem is given, the current is given, magnetic field is given. You have to find the force per unit length, F over L. We know the formula where magnetic force is equal current carrying wire. So in that particular case we have formula current multiplied to the length multiplied to the magnetic field, and FB over L will be equal to the current times B. So again you plug the numbers of the I and B and you will get FB over L. Problem number 8. In the problem number 8, we have given a current. We have experiences a force on 4 centimeters of the wire field. What is the average field strength? So you have to find magnetic field. This is problem number 8. So F is given, L is given, and also the current is given, I believe, right? Problem number 8. Yeah, current is also given. So again, you just use this formula which is used in the problem number 7, where FB is equal I times L times B, and from here you have to find a B, magnetic field, which is magnetic force divided by current times L, length. Okay, problem number 9. What is the maximum torque on 150 turn square loop of the wire, centimeter on the side that carries current in the field? Okay, so we have number of turns, square loop of the wire, side as given, current is given. So we have to find torque. Okay, so let me write down all the given values. Problem number 9, we have square loop, the sides are given, which is L this one, L this one, and number of turns, so it means like many this kind of things. Okay, number of turns. So we have L is given, the number of turns is given, magnetic field is given, current is given. You have to find a torque. Okay, so we have a formula particular for the torque, where torque is equal number of turns multiplied current multiplied area of this loop. So the area is basically L squared because it's a square, area times magnetic field times sine theta. So number of turns is given, area just L squared, and when you do calculate it, sine theta in particular case it will be equal to the 1, and that should give you the answer. Okay, what else? So problem number 10, calculate magnetic field strength needed on 250 turn square loop. Again, this is also square loop, 20 centimeter side, create maximum torque if the loop carries a current. So we have to find magnetic field strength. So problem number 10, again this is square loop, many wires on it because of it has number of turns. So N is given, L is given, torque is given, and current is given. Again, you use that formula where torque is equal number of turns multiplied current, magnetic field, area, and sine theta. Now in this case also it will be equal to the 1 sine theta. Magnetic field is equal torque divided number of turns, current, area, okay, so yeah, that's it. So everything is given, and area is simply, if it's a square, so L squared area.